Like my
Hey,
beard?
hey, Mark, I love your beard. It's I don't know that you call it a beard. It looks like something else.
Remember back in the 70s, was that band Jethro Tull? They had that album Aqualung. Like that's kind of the look I'm going for.
You know what I was trying to figure out is I heard a rumor that maybe you were sticking your face into a mask and then sticking your whole body into water.
Oh, you're right. I was diving in Florida, and yeah, this is not conducive to a waterproof seal. So it's a
You know what
little
I kept wondering? Every time I scuba or snorkel, I wonder how come water starts creeping in underneath the bottom, and I keep thinking it's a bad mask fit.
it's because you're eternally smiling. You're just a little ray of sunshine into the black abyss.
You got that right, Mark. Why, thank you for noticing. So, hey, Mark, today we've gathered here to talk about a topic that's very interesting to me, which is securing AI. Our customers put tremendous amount of work into getting to some type of AI, and like a lot of things, the value that we produce through all of that work means that bad guys might want to steal it. And so I'd love to get your help to walk through with me kind of the body of how people develop what we call an AI, and where the places are that we can have some compromise that we have to watch out for.
Yeah, no, you bring up a super good point. Our customers are kind of making that transition from using products with embedded AI into building their own custom models that the customer takes some huge body of data and they pare that down into the data that's pertinent to the problem they're trying to solve. And that sample set is used to train a blank model to where it can do some sort of pattern matching upon that data. Well, every one of those steps has a security vulnerability to it. AI introduces a number of different areas that baddies can go ahead and attack. Let me go into a couple of them. But by the way, we run a multi-billion-dollar special effects budget here on Technically Speaking. I'm going to go ahead and I'm going to switch cameras so that I'm like kind of in this. Look at that. I think I look more sinister. Is this sinister?
Very much so. Very much so.
Pretty sinister. Yeah. So a baddie can actually start by attacking that corpus of data that's out there. So you can imagine if it was a bunch of images of roads and signs and cars and things like that, and we were going to go ahead and use it to train an autonomous vehicle. If a baddie went in there and took out all of the stop signs, you could probably still train an autonomous vehicle and it would probably run fine until it encountered its first stop sign, at which point insurance rates all go up, right? So that's called data poisoning.
Mhm.
There's another technique called data biasing. And this is where we don't actually inject erroneous information. What we do is we tamper with the selection criteria. What if we made it to where that selection criteria never, ever picked out images that were taken at night? Again, we would train very well and our car in the daytime would navigate perfectly. However, the first time that it got a little bit dark, things would go awry. So that data biasing, you can imagine if we were making an AI app to come up with mortgage rates based on risk, that if you tampered with the demographics of the data that was being used to train this, I mean, you could get some very unethical results that come out of that.